Hey, so since this is a review, I want to make sure that we understand how to do each of these problems, so I'm doing a video for you guys. So I hope that this helps with anything, and I hope that you guys appreciate me taking time to do these videos. So anyways, here we go. Review 3.1 to 3.4. We're going to find the limit as, that should say as h approaches 0, of f of x plus h minus f of x all over h. So this is using the definition of derivative. So that means that we're taking a derivative. We're being asked to take a derivative at an x value of 5 of f of x. So let's find the derivative. So f prime of x equals, I'm going to use power rule, 2x plus 2. And now let's find it at an x value of 5. So 2 times 5 plus 2, so 10 plus 2 is 12. Number 2 says sketch a possible, I thought it said positive, possible graph of a continuous function f that has domain -3 to 3, where f of -1 equals -1, and the graph of y equals f prime of x shown below. Okay, so this first graph that we have given here, this is the derivative. So that means that these are the slopes. Okay, so we know that when we get something like this is usually going to be a corner or a cusp. Okay, and let's see, it looks like we have a couple turns. We have a turn right here, right here, right here. Wherever we're hitting the x-axis at, that's where we're going to have a horizontal tangent. Or above the x-axis here, so the slope is positive. We're below the x-axis here, so the slope is negative. So to go from positive to negative, that means I have to be a maximum. Going up, positive slope, and then down, negative slope. Okay. For this turn, we have some below the x-axis, so negative slope, and then some above the x-axis, positive slope. So to go from negative to positive, that means that this must be an upward facing U. Negative slope, positive slope. Okay, right here there's got to be a corner or a cusp of some kind, and because I'm going from a positive slope to a negative slope, that means it must be an upside down V like that. Positive slope, negative slope. And then over here I have some negative slopes on the left of that point, and then positive slopes on the right of it. So to go from negative to positive means that we have a upward facing U, a minimum again. Negative slope, positive slope. Okay, so I know what I need to have on my graph. Now let's place those things that we need on the graph. So first of all, it did say where f of -1 equals -1. So when x is -1, y is -1, we need to have that point on the graph. So that has to be on there. Okay, and then looking at this, at -2, there needs to be a downward facing U. So if this is -2, let's see, let's have a downward facing U there. Okay, and at -2 I would have a horizontal tangent, so it would be a slope of 0 there. Okay, and then I need at -1, I need it to be a minimum, so I actually should make this curve a little bit more. Needs to be a minimum. Okay, and then when we get to a +1, a +1, I need to have a cusp or a corner there. So we'll make it go up here. We'll make that little cusp. And I know what's coming up next is a U, so it's got to have a little bit of a curve to it. So it's an upward facing U at +2. So I just need the vertex to be right above the 2, and then this goes up. So it looks like that. Okay. Now, you could have this placed higher or lower. The only thing we know for sure is the point -1. That's the only thing because it was given to us as being on the graph. But everything else, the highs and lows, we don't know how high up and low the y-axis is except for that 1 point. Okay, so answers could vary on that one. Number 3, which of the following describes the behavior of y equals the absolute value of x squared minus 16 at x equals 4? Okay, so this is where we have to take it to our graphing calculator. So let me see. Y equals, I need the absolute value, so math, scroll over to num1 for absolute value, x squared minus 16, and graph. But I don't see what's going on from at +4, so I'm going to change my window. Let's go from -5 to +5 so I could see what's happening at 4. Ah, it's one of those. Okay, so at -4 and +4, we have a corner. It's doing the Batman symbol. Okay, so which of the following describes the behavior? A, differentiable? Nope, it's got corners. So at +4, it's definitely a corner, so it's continuous, but not differentiable. Discontinuous? No, it's continuous. It's just not differentiable. Vertical asymptote? No, not really a vertical asymptote there. A hole? Nope, there's no holes. A corner? Yes, that is the true definition of a corner. Can't really see that good, so I'm going to highlight it. Okay, number 4. Says use your graphing calculator, so hopefully it's not too far away. Nope, it's right over there. To find f prime of x if f of x equals the cubed root of x minus 2. So we're going to use this to find the derivative. So to find the derivative, we hit, what was it? Is it math? 8 for n derivative. So d dx of the cubed root of x minus 2. So I need a cubed root, so I think I need to hit math. And if I look down at 4, there's the cubed root, so I'm going to hit 4. So cubed root of x minus 2. And the only thing that 4 is missing at what x value? So this was our bad for not saying that it's at an x value of x equals 2. And it's at an x equals 2 because it was shifted to the right too. Let me look at the graph. So I'm going to type in a 2. So if you got stuck on that one, you had good reason to be. It says it's 100. So I'm going to write this as d dx of the cube root of x minus 2 at x equals 2 equals 100. All right, letter B. Now graph f of x and see if your answer to part A makes sense. Okay, so back in Math 3, first semester, we learned how to graph these. So this is being shifted over to the right 2 times from the parent function. So if I draw a little graph, shift it to the right 2. And this is a cube root function, so it makes the funky S. Okay, so if this is a positive 2, what's the slope of the tangent line at that x value? Well, tangent line, well, we've got a shelf there. So we have a vertical tangent. Okay, so does this make sense with this? It says here the derivative is 100. Here this is a vertical tangent. And the slope of a vertical line is undefined, so it does not exist. So does it make sense? No. It has an undefined slope at x equals 2. So the derivative does not exist. D and E. If I can grab these pages, that'd be great. There we go. Number 5 says find dy dx of y equals 4x to the 5th minus 5x cubed minus 7x squared plus 4x plus 20. I'm gonna use the power rule since it's ready to go that way. So drop down the 5. 5 times 4 is 20. Drop it down in exponents, x to the 4th. Drop down the 3 times negative 5 is negative 15. Drop down the exponent to a square. Drop down the 2. Negative 7 times 2 is negative 14. Drop down the exponent from 2 to 1. Drop down the 1. 1 times 4 is 4. And then x to the 0 is just 1, so it's just 4. And then anytime you take the derivative of a constant, it's 0. So this is the derivative. Okay. Number 6 says, suppose that u and v are differentiable at x equals 2, and that u of 2 equals 4, v of 2 equals negative 9, u prime of 2 equals 5, and v prime of 2 equals 3. So for part A, it says find d dx, so the derivative of 6uv at x equals 2. And up above it says hint product rule. Well, 6 times u times v, those are all a product. But 6 is a constant, so what we can do for this product is just put the 6 way out front and just take care of the u and the v. So using product rule, it's the first times the derivative of the second plus the derivative of the first times the second. Well, they gave us some things to plug in, and this is at an x value of 2. So I'm going to have 6 times, inside I'll have u. Well, u of 2 is 4. V prime of 2 is 3. Plus u prime of 2 is 5. And v is negative 9. So we have 6 times, 4 times 3 is 12. 5 times negative 9 is a negative 45. 12 minus 45 is negative 33. Multiply that by 6, and we get negative 198. So that is the derivative of 6uv. All right, letter B, we're finding the derivative of u divided by v, u over v. So that means we're going to be using quotient rule. So we're going to have low d high minus high d low over low squared. So low is v. The derivative of the high would be u prime minus high, which is u, d low, so derivative of the denominator, so v prime, all over low squared, so v squared. Okay, let's substitute in what we know. V of 2, because it's at an x value of 2, is negative 9. U prime of 2 is 5. Minus u of 2 is 4. And v prime of 2 is 3. All over v squared, so v is a negative 9, so negative 9 squared. Well, negative 9 times 5 is negative 45. Negative 4 times 3 is a negative 12. Over negative 9 squared is a positive 81. Negative 45 minus 12, that's what, negative 57. And that reduces, let's see, I think it only reduces by 3. So let's try. Negative 57 divided by 3 is negative 19, yeah. 19's prime, so that's as low as I can go. And 81 divided by 3 is 27. So negative 19 over 27. Number 7. A particle moves along a line so that its position, where s is measured in feet and t is measured in seconds, is given by this. S of t equals negative 16t squared plus 60t plus 100. Find the displacement during the first 5 seconds. So anytime you see the word displacement, they're talking about the distance traveled. And I pointed that out in the notes also. I was about to spell that wrong. Okay, so that means we need to figure out, okay, well, what's the distance at s of 5 seconds, and what's the distance at 0 seconds? So over to the left, I'm going to find that out. S of 5. Well, if I plug in a 5 for t, 5 squared is 25. So negative 16 times 25. And then plus 60 times 5. So plus 60 times 5 plus 100 is 0. So s of 5 equals 0. Let's try s of 0. That one should be way easy. I shouldn't need a calculator for that. So you plug in a 0. That gets wiped out. That gets wiped out. All I have left is 100. So the displacement would be s of 5 minus s of 0 to see the difference in distance traveled. So that'd be 0 minus 100. So it's negative 100 feet. So because it's negative, that means that it's going left, because that's a negative direction, or backwards. Okay. Letter B says find the average velocity during the first 5 seconds. Okay, so now we need to find average velocity. So we're using the slope formula. So I'd be using s of 5, I don't know why I put that set of parentheses there, minus s of 0 all over 5 minus 0. So s of 5, remember we just got was 0, and then s of 0 is 100 over 5 minus 0, so that's basically negative 100 over 5, which equals negative 20 feet per second. That was easy. The first problem pretty much leads us right to this one. All right, letter C, find the instantaneous rate of change at t equals 5. That means we're taking a derivative. I like to write myself these notes. All right, so we're finding v of t, which means we're taking the derivative of the position function s of t. So using the power rule, we have to drop down the 2. 2 times negative 16 is negative 32 t. It would just be plus 60. And then the derivative of 100 is 0. Okay. So, but it needs to be at t equals 5. So now we need to plug in 5 into our little formula here. Negative 32 times 5 plus 60 is negative 100. So the instantaneous velocity is also negative 100 feet per second. Letter D, find the acceleration of the particle when t equals 5. So acceleration means that we're taking a second derivative, okay? So we're finding a of t, which means we're taking the derivative of the velocity function, which means we're taking the second derivative of the position function. So I'll go back to letter C right here, the derivative of this, v of t. That would just be a negative 32. Oh, that was easy. So it's negative 32 feet per second squared. So remember, it's the square units in the denominator when we're finding acceleration. Okay, letter E says, at what value or values of t does the particle change direction? Give a reason. So let's do a quick little number line. And to figure out where it changes direction, that means we need to find, well, when is it at rest? Because before it's getting to rest and after it goes from rest, that's where it's switching directions. So that's where we set the velocity equation equal to 0. So the velocity one is this one. So 0 equals negative 32t plus 60. And solve for t. Subtract 60 from both sides. Divide by 32 on both sides. Let's see. Negative 60 divided by negative 32. And negative divided by negative is positive. So it's going to be 1.875. So the time is 1.875 seconds when it's at rest. Okay. So on my little number line, if I have 1.875, this is where it's at rest. Okay. Before you hit a 1.875, you would hit maybe a 0. And we know at 5, on the position, we need to figure out what that is, at the velocity. So at a velocity of 0, if we plugged in a 0, it would be positive 60. So we know it's positive. If I plug in a 5, negative 32 times 5 is negative 160. And, well, we already found that. Where was it? Over here. Negative 100. So we know it's negative at 5. So it goes from positive to negative. So it switches direction, positive, negative. Okay, so what was it asking? At what value of t does the particle change directions? Oh, just when does it change directions? Okay. So we could say the particle moved in the positive direction for t in the set from 0 to 1.875. Okay, we can't equal the 1.875 because that is when it's at rest. And then it turned at 1.875 seconds. The turn implies it goes in a different direction. And it did. It went in the negative direction after that. All right, number 8, I think. Yeah. What did I just do? Just a number 7. Sorry, I got confused for a second. Everything started looking the same. Must be because it's Monday. All right, differentiate. Oh, I love these. Okay, so I have a quantity divided by a quantity, so I'm going to be using good old-fashioned, oh, go away here, quotient rule. Okay, so remember, low di minus high d low over low squared. Low, derivative of the high, the derivative of 2x minus 3 would be a 2 minus high. Derivative of the low would just be a 1 all over low squared. X plus 5 quantity squared. Okay, well, if I were to distribute that 2 to the x plus 5, I would get what, 2x plus 10? And 2x minus 3 times 1 is still 2x minus 3, but we have to distribute that minus sign. So we would get 2x plus 10 minus 2x, and the negative times negative is a positive 3. All over x plus 5 quantity squared. 2x minus 2x is 0. They gone. 10 plus 3 is 13 over x plus 5 quantity squared. There it is. I hope these are helping. Number 9, y equals the 5th root of x times 3x minus x squared. So we do have a quantity times a quantity. So we could use product rule. But I tried product rule at first, and it's tricky. So it's easier to use power rule on this one because we can distribute. Okay, but before we distribute, let's convert this so that it's an exponent, so that the fifth root of x is the same as x to the 1/5. We have to do that part, and you would have to do that part anyway, even if you use the product rule. Okay, so we haven't taken a derivative yet. We're going to distribute x to the 1/5 times 3x. Well, let's, instead of an x to the first, let's make it, it's still the first, but let's make it have a common denominator. So that'd be a 5/5. So when we multiply like bases, we add the exponents. 1/5 plus 5/5 is 6/5. So that would be 3x to the 6/5. And then x to the 1/5 minus, or times negative x squared. Well, I know it's going to be negative. And let's change the exponent here so that it's equivalent with a denominator of 5. So a 2 is the same as 10/5 because 10 divided by 5 is 2. So when we multiply like bases, we add the exponents. 1/5 plus 10/5 is 11/5. So we would have x to the 11/5. Okay. Now it's going to be super simple to do power rule. Okay. So let's do this. Y prime equals. We'd have to drop down the 6/5 in front and multiply it times 3x to the, but we have to subtract a 1, so subtract a 5/5. 6/5 minus 5/5 is 1/5. And then minus, drop down that 11/5. And we'll have x to the 11/5 minus 5/5, so we have to subtract 1, and that would be 6/5. All we have to do is simplify this part right here. 6/5 times 3 pretty much would be 18. Oops, that's a 3 over 1. 18/5. X to the 1/5 minus 11/5 x to the 6/5. And we can leave it like that. It looks way better than when I tried to use the product rule on that. Sometimes power rule is better, sometimes product rule is better. Use the method that doesn't get you stuck, pretty much. Number 10, describe how the particle moves, increasing or decreasing, and at rest, that has a position of x of t equals t squared minus 12t, t cubed minus 12t squared plus 36t plus 5. Show your analysis and explain your reasoning. So let's start with when the particle is at rest, which means I need to take the derivative because we're looking at the velocity. So x prime of t, that gives us the velocity of t. So that would be, using power rule, 3t squared minus 24t plus 36. Okay. Now let's look at it when it is at rest. So at rest means that the velocity would be 0. So 0 equals 3t squared minus 24t plus 36. Well, I have a quadratic and it's a trinomial. So let's see, do we have a common factor? Yes, I believe they all have a common factor of a 3. So let's factor that out first. Negative 24 divided by 3 would be negative 8. 36 divided by 3 is 12. Okay, so now I have an easy trinomial that I could factor if it's factorable. So let's see, the product would be 12. The sum would be a negative 8. So, it won't be 4 and 3. It's got to be 6 and 2, but both have to be negative. So t minus 6. T minus 2. So when I break these apart and set them each equal to 0 and solve, we'll get t equals 6 and t equals 2. So these are the 2 times when the particle is at rest. So let's go ahead and draw a little number line graph to show the position. So let's see. 0, 1, 2, 3, 4, 5, 6. So we know we're at rest right here and right here. Well, what's happening around that? So let's try at a time of 0, so if I were to plug in a 0, I would get 36. That's positive. If I plug in like a 3, let's see, 3 squared would be 9. 9 times 3 is 27. I'm going to use my calculator now. 27 minus 24 times 3. And then plus 36 would equal a negative 9. So it would be negative over here. Okay. So it's changing from positive, resting, this is where we're turning, to negative, and then it comes back down to rest. Okay. So I'm going to start by talking about the rest, but you can end with talking about the rest. It's totally up to you how you do your write-up, but it has to have all these key points. So the particle is, I'll start with increasing, is increasing, so that means it's moving in the positive direction. When t is between 0 and 2, so 0 less than t less than 2, it can equal 0. So, okay, for times 0 to 2. Okay, it can't equal 2 because that's when it's at rest. And particles increasing and decreasing when, so it's decreasing between 2 to 6, so 2 less than t less than, oh, it can't equal the 6, sorry, because that's at rest. So it's just, this is just a less than symbol. Okay. The particle is at rest at t equals 2 and t equals 6 seconds. Really not that bad. We're just describing the motion. Number 11, write the equation of the tangent line to the curve at x equals 2. Okay, so we have the x value. We're going to need to find the y value at some point, so might as well do it now. So y is going to equal, just plug in the 2 for x, 4 times 2 cubed minus 3 times 2 plus 2. 2 cubed is 8, 8 times 4 is 32, 32 minus 6. I can't think in my head all of a sudden. 32 minus 6 is 26 plus 2 is 28. Okay, and so that means that when x is 2, y is 28. We're going to need that for the equation of the tangent line. Tangent line means we're finding the slope of the tangent curve, so that means we have to take a derivative. So that's the next part. So the derivative of y, so y prime would equal, let's see that, using power rule, 12x squared minus 3, okay? And it's at an x value of 2, so we need to plug in a 2 for x. So 4 times 12 is 48 minus 3. So the slope of this tangent line is 45. Super, super steep positive slope. All right, so t of x equals 45 times the x value is a 2, so x minus 2, and the y value is a positive 28. Whoop, there it is. All right, last page to the back side. Sorry, this is so long. I just want to make sure I explain everything good, and so I'm trying not to rush, and so I'm sorry if it's really long, but I hope it helps. The figure below shows a graph of f of x, of g of x, which statements are true. So this is the graph of g of x. So this is an original graph. I don't know about you, but I have to tell myself if it's an original graph I'm dealing with or if it's a derivative graph, because we handle those very different, as you guys can tell. All right, so the limit as x approaches negative infinity, that would be this way, of g of x, so the original graph, equals 2. Yeah, we're approaching that horizontal asymptote, so that is true. True. All right, the limit as x approaches positive infinity of g prime of x equals 0. Okay, as we're going towards positive infinity. Now we're looking at the derivative. So on this side, as we're approaching infinity, we have negative slope, negative slope, negative slope, and it's getting closer and closer to a flat line. So is it approaching a derivative of 0? Yeah, we're approaching a horizontal line, and slopes of horizontal lines are 0. All right, g prime of x, the slopes of g, pretty much, are less than 0 so negative, for x less than -2. So for x smaller than -2, so from here to the left, the slopes of g of x are going to be smaller than 0. Negative slope, negative slope, negative slope. Yeah, they're going to be smaller than 0. That's true. Those are negative slopes. So true, true, true. They're all 3 true. So all 3 would be D. Number 13. Given the derivative, x prime of t, graph x of t. Okay, so this one is the derivative graph. So these are slopes. Okay, so when we're looking at the slope graph, we need to look at where it crosses the x-axis. Okay, so we're touching here, here, and here. So we're going to have 3 turns. Okay, use a brighter color. So at this turn, on the left we have positive slopes, on the right we have negative slopes. So that means to go from positive to negative, I have to have a maximum. Okay, because we have a positive slope here, negative slope there. Then at 0, we have negative slopes and then negative slopes. But there's a turn right here. So the only way for it to stay negative and then continue negative means that we have a shelf. Negative slope, negative slope. So we've got a shelf going on right here. And it would be a shelf the other way if it were positive, positive. All right, for this turn, we have negative slopes on the left and positive slopes on the right. So that means that we have to have a minimum. Negative slopes, positive slopes. Okay, so it's nice to have the derivative graph directly below because then we can kind of line it up. So at -3, I don't know how high or low the y is, so I'm just going to go up here somewhere. I need to have a maximum, and I need that peak to be right above the -3. Okay, so I know that it's going to have that horizontal tangent up there. Okay, and then once we hit the y-axis, it's going to have a shelf, so it's got to come down with a negative slope, shelf out, and then keep coming down. So it's going down. Okay, and then at +3, I need to have a minimum. So I just need to make sure that I have a minimum right here. So I'm going to go like that. Okay, and then I will have my shelf right there, or my horizontals in those 3 spots. So the key is looking for where the derivatives are crossing or touching the x-axis, and then looking at the positive and negative slopes to tell you if it's going to be a maximum, a minimum, or a shelf, pretty much. And that is everything. I hope this helps. Let me know.